Most circuits are not purely series or parallel, but a combination of both. To solve complex circuits, we simplify it in steps. Let's look at this example. First of all, we have 8 omega and 4 omega resistor in series combined into 12 omega. And then we have the 6 omega and the 3 omega resistor in parallel combined into 2 omega. Those 12 omega and 2 omega are then in series, so we simply add them up to 14 omega. In this type of combination circuit, we would first simplify the parallel combination of R1 and R3. The resulting equivalent resistance would then be in series with R1. R1 is in series with those two in parallel. In this second example, we would simplify R2 and R3 in series first, and then the equivalent resistance of R2, R3 are in parallel with R1. Let's try to do a simple example. We want to find the equivalent resistance of the network and the current in each resistor. The EMF is 18 volts with negligible internal resistance. So first we calculate what's the equivalent resistance of 6 and 3 in parallel. It also makes sense. Let me just call this one R1, R2, R3. So first R2, R3 in parallel. So let me call the equivalent resistance of R2, R3 in parallel R2, 3. It should be given by R2 times R3 over R2 plus R3. So it's 3 times 6 over 3 plus 6. Give me 2 omega. Which should be right because the equivalent resistance of parallel connection should be smaller than the lowest one, which is 3. Now, this equation, of course, is coming from 1 over R2, 3 equals 1 over R2 plus 1 over R3. And then we can simplify the circuit to R1, R2, 3, and R1 and R2, 3 are in series. R1, so let me call the total equivalent resistance 1, R1 to 3. It should be the direct sum of R1 and R2, 3. So it's 4 plus 2, 6 omega. Okay, so we find the equivalent resistance. Call this one R1 to 3. This is 18 volt, and R1 to 3 is 6 omega. So the total current going through the circuit is V over R1 to 3, 18 over 6, 3 ohms, 3 amperes. Okay, so which means the current going through here is 3 amperes, which also tells us for R1, V1 equals to I times R1. I is 3, we just calculate. So it's 3 times 4, 12 volt. So V1 is 12 volt, which means the potential on R2 and R3 add to 12 have to give us 18. So V2 equals to V3 equals to V subtract V1 equals 6 volt. Now, if this is 6 volt, then the current going through here is 6 over 6, 1 amp. The current going through here is 6 over 3, 2 amperes. And you can check 1 plus 2 equals 3 because current is split at C.